Okay, so this is your review for test number 1. So we're going to start off with section 1, 1.1, which was inductive and deductive reasoning. And the difference is that inductive reasoning is you make observations, whether they are an experiment or whether they're just observing everyday events and then making some conclusion. And so what you have to do is say whether it's inductive or deductive reasoning. So theoretically you have 50% chance of getting it right, even just guessing. So I'm going to pick out some problems in the book, so hopefully you'll have your book. And I'm not going to write it out. I'm going to let you be able to read it. So this is on page 7. So if you need to just pause your recording right now until you get your book out. So this is problem 10 on page 7. So the problem statement says, for the past 97 years, a rare plant has bloomed in Colombia each year, alternating between yellow and green flowers. Last summer it bloomed with green flowers, so this summer it will bloom with yellow flowers. So the question is it inductive reasoning? And so when you read the problem, you'll basically see there's experience. It's not really a experiment, but it is gathering data. Somebody has observed that over the last 97 years it's alternated between yellow and what's green, I guess it is, yellow and green. So there's no overall law that says this plant alternates between yellow and green always, but there is experience that has shown this is happening. So we're basically going from observations to making a conclusion. So the conclusion is, since the observation that they're going to use to predict the next thing is, it said last summer it bloomed green. So last summer it's green. Then this summer, which is the alternate summer, the question is, what would you think it would be if you were using this past experience? Well, you would say, well, it goes yellow, green, yellow, green, yellow, green, so it must be yellow. So this is a case of inductive reasoning. Again, you're using observations. Those observations then allow you to come up with some premise. So our observations were this. Our premise was that it alternated between the colors every year. Then you use that premise to predict. So we use the observations to come up with premise. Then we use the premise, which may be right or wrong, but based on our observations here, we have to think it's right to make some conclusion about what would happen given some future information. Okay, so that's inductive reasoning. Now, in terms of a deductive reasoning, that's where you start with some kind of mathematical law, a rule, some physical law or rule. And from that rule, you make a conclusion about what will happen for a specific case. So it's basically start with a law that applies to everything, and then you apply that to a specific example. So this is called deductive reasoning. So what I would suggest is you write these things. Inductive reasoning, you go from observations to a premise, and then premise to make a conclusion. Deductive reasoning, you start with a law and you apply a specific example. And then you look at the homework and the examples we did in class. So I'm going to use number 6 as an example of deductive reasoning. Number 6 says, if the same number is subtracted from both sides of a true equation, the new equation is also true. So that's the law. It's just a mathematical law. Applies always. Therefore, so the therefore is you're going to apply that law to a specific example. So they give the example of 9 plus 18 minus 13 equals 27 minus 13. So this part is 27. This part's 20. So really, you're starting off with this original equality, which is just adding numbers together. 9 plus 18 is 27. So that's a true statement. It's a true equality. And then you subtract 13 from both sides. And so that would be the conclusion, is using the law that says if you have a true equality and then you subtract the same thing from both sides, that the equality remains the same. So I'm going to tell you in your book which ones are inductive and which are deductive, so you can look at all the examples 1 through 12. So what I'll do is I'll say inductive examples, deductive examples, reasoning. So the problems that are deductive are 1, 2, 5, 6, 7, 8, and 8. Okay, and the inductive reasoning ones are 3, 4. There should be all the other ones I haven't listed so far. 9, 10, 11, 12. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are sections 1, 1. Okay, second one is, second kind of problem is to use inductive reasoning to predict the next number in a sequence. Remember, there were two kinds of sequences. There were arithmetic and geometric, even though you don't need to use that in coming up with the next term. So I'm just going to make something up here. And so let's say we okay, so there you go. That's the sequence, and then try to figure out what the next one is. And I didn't give you a simple one, but a lot of times you just look at corresponding numbers and see if you can see a pattern. So in this case, if you looked at a pattern, the difference between the numbers, you would find out that 5 minus 3 is 2, 9 minus 5 is 4, 15 minus 9 is 6, 23 minus 15 is 8, and therefore you'd expect the next number difference to be 10. And so we'd use inductive reasoning to pick the next number as 33. You know, we have two special kinds of sequences. One is, this is arithmetic, and you have a common difference between the two. So there's a difference. So again, if you just look at the difference between them, you'll see that this is the same. And so then you can predict the next value, which should be 12. The other one that we have a name for is geometric series. And so this would be an example of a geometric series. So in this case, if you take the differences, you'll see it's not the same. But you can see the difference has a pattern to it. This is double that, that's double that, that's double that. Also, the numbers are double each other. This is a geometric series. Here, in the previous example, this is called the common difference for the series. This one is this ratio. So instead of having a common difference, what you would find out is that if you take the ratio of neighboring numbers, you would end up with this. So 4 divided by 2, 8 divided by 4. You'll see that all those simplified when you simplify the fraction to 2. So this number here is the common ratio. So back to the test. I may put one that may be an arithmetic or geometric series, or I may do something like this, which is not either one of them. And you look for a pattern. And the best way to do is to subtract adjacent numbers and then look to see if you see a pattern in the difference. So if there's the same difference, then it's an arithmetic series. If the difference is a power relationship, then it's a geometric series. If it's something else, then it's something else. So basically what you have to do is predict the next number in the sequence. Okay, then you had a similar kind of thing. This is problem 36, where they gave you some other kinds of patterns that were mathematically related. So what you have to do is figure out what the next line of the pattern is. So I would give you three examples or 4 examples. You would use inductive reasoning to establish a pattern, and so what you would hopefully do is see there's 2 1s, 3 1s, 4 1s, so there has to be 5 1s for the next line. And then, for both of them, then if you multiply them together, notice you go 1, 2, 1, 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1. So you'd go one number higher, 1, 2, 3, 4, 5, 4, 3, 2, 1. And that would be an example, so you have to figure out what that is. Okay. Be familiar with Gauss. Gauss is the student that grew up to be a great mathematician, where he looked at the problem of, say, 1 plus 2 plus 3 plus all the way up to some number, let's say 200. And what he realized was, well, what if I put 198 and 199 in just to get an even number of, this is actually plus, not an even, but there's matching things. And you can see when you add the first number and the last number, you get 201. And when you do the next to first and next to last, you add those together and you get 201. 199 plus 2 is 201. And you see that happening. And it's going to happen 100 times. There's going to be 100 matches. So actually, yeah, there's going to be whatever this number is. So there's going to be 200, which is the maximum number, divided by 2 equals 100. So there's going to be 100 pairs of the number 201. So what does that mean? Well, it means there's going to be 100 of the 201s when you add them together. So you take this number divided by 2, multiplied by what the sum is of the first and last number, which is 201. And then you get your calculator out and you do that multiplication. So we get 100 times 201, which is 20,100. Remember the one we did in class, or Gauss did 1 plus 2 plus 3 plus ... up to 100. In that case, when you match up the first and last, you get 101, and there are 50. You take that number, divide by 2, you get 50. So if you multiply 50 times 101, you'll get 5,050. So that's how it works. And obviously I'm not going to ask you either one of these. So it'll be some other number, probably some even number. If you have an odd number, it's a little bit different. Okay, so that's all section 1. The next section looked again at patterns, and I've already talked about the arithmetic and geometric series. So be able to identify whether a series or sequence I should say, sequence is arithmetic or geometric. We already talked about what those were previously. That's, you're going to have, and then you also predict the next number. Okay, method of successive differences. So we went over that in class. It takes a long time, so I'm just going to tell you to find the homework example problem. Make sure you understand it. So what you ended up with is, you know, a bunch of numbers up here, and they don't look like there's any there's any kind of pattern to it, except that the next one's larger than the previous one. But what you do is you take the difference between these two, the difference of those two, and so forth and so on, until you get to the next level, which will have one less number than the one up here. And you continue down doing the same thing, taking the difference between adjacent values, and you'll get to some point where you have the same number here, here, and here. So this will be the same. That way, at that point, you say, okay, I understand what's going on, and then you know, fill this out the right-hand side. So if you can't figure it out from looking at the notes or looking at the homework problems, come by and see me. Okay. Then there's another one that looks at, again, looking at patterns and predicting what the next one is. So it's very similar to this. And the only difference is that here you just fill it in and you got to write, I could have asked you to verify this is true. So what you would do to verify that it's true is you would take the last equation, or even just previous ones, and just plug into your calculator. So if I multiply 11 times 11 in my calculator, I'll get 121. If I take 111 times 111 in my calculator, I'll get 12321. So how do you represent that on a test? What you would do is you would say, you might start with this, and then you would do this multiplication, and then you would write out that 1, 2, 3, 4, 5, 4, 3, 2, 1, which comes from this calculation, matches up with the answer that was given on the right-hand side. So that's how you verify it. You do the calculation and stick the answer in. Okay. And we didn't talk about it in class, so I'm probably going to change that problem. So I'll make it something that's I had before. Let's see, reading graphs. So what does that mean? Well, it means that I will give you some kind of graph, probably a bar graph. So you'll see something like this, and there'll be just some bars. And let's say here they are. It's 3 bars just to make it simple, but there'll actually be more than that. And if I were to put some units over here, and let's say this is June, July, August, and this is something like electricity usage. So I might ask a question, which month uses the most electricity? So you come over here and you go, oh, that's the one with the big bar in there. So you say July. I might say what is the amount of electricity used in July or June? I'd go over here, I'd go to the top of the bar, I'd go to the left and read off, find out where it intersects this axis with the scale on it, and then I'd have to estimate. And you think you might not be able to estimate that much, but say it's here, that's going to be halfway between 400 and 200. So that would be 300. You can actually mark in here if you want to put some yourself put in some additional marks to help you remember, this is 300 and this is 500. So let's say I asked what August was. What's the amount in August? You would take that and you would probably best to draw a line over just to make sure you're getting it straight. Once you get over there, you could approximate it. So you might say it's 400, you might say it's 390 in terms of the value. And then the question might be, besides what's the biggest or smallest, what's the actual value, reading off the axes, or I might say between which 2 months is the biggest change. So you look for the difference between here and here, and then you see which one is the biggest difference. So the difference from here to here is there. This was from there to there is smaller. So this from June to July, you'd have the biggest difference. Okay, so we skipped over problem solving because, you know why? Because the problems are too hard. Okay, then we talk about sets. So you want to be able to use the listing method to describe a set. So what I may do is give a word description. So what I might say is the set of all negative integers. So that's the word description. The set of all negative integers, let's say greater than negative 19. I wouldn't give you one this hard because some of them you probably are not super great at negative, but we'll talk about that at some point. But right now I'm not gonna subject you to that. So it'll probably be positive numbers, but I'm just using this as an example. So what you would do is you would write it in, just list all the elements. The listing method doesn't mean just list the elements. You have to put that little bracket in there. And so I want to list all of the elements, not just using an abbreviation. So I would use negative 18, which is one greater than that, so it's greater. You'd have negative 16, negative 14, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, and then close the bracket. So that is a list of everything. The abbreviated version of this, if I was going to do the abbreviated version, I would write the first 3 elements from the smallest. Once I've established this pattern of a difference of 2, then I would go dot, 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 put in another comma, and then I would put the largest number. And that would say I want to go 2 at a time, go by 2s, and excuse me, until I get to negative 2. So that would be a short way of doing it. So for example, that would be the other way around. If I gave you an abbreviated version, so let's say I said, list all the elements in the set. Let's see what I'm going to do. Let's say negative 7, negative 6, negative 5, dot, 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 negative 2. So this is what I would write down, and what you would write down is everything. So you would say, oh, okay, the first 3 numbers are negative, and they're getting larger, more positive, so I would go ahead and fill in those 2 additional numbers that were left out here by using the abbreviation. So list method means list everything, either starting from words or starting from description, from a abbreviated set list. Okay. Now I may give you something like this, list. Okay, what I say is using the listing method, so you'll see listing method. Take the following expression, this set of all integers let's see, greater than or equal to 4, or actually and less than 12. Okay, so I've combined two things. I have greater than or equal to 4 and less than 12. So there's the word description, and what you're going to do is you're going to list it in the abbreviated version. So you don't have to list everything if you don't need to, because I may give you something that's so long you wouldn't want to list everything. So I'm going to use the abbreviated version here, and then so what I do is I'd say, okay, it's greater than or equal to 4, so I do include 4. If it just said greater than, then it would start at 5. So you go 4, 5, 6, dot, dot, dot. So I've established a pattern starting at 4, equal to 4, 1 increase, and then less than 12, so I got to read that carefully, less than 12, which would be 11. So if I said greater than 4 and less than 12, this one would go. If I said greater than or equal to 4 and less than or equal to 12, then I have an additional term. I might also ask in terms of set builder notation. So the set builder notation would look something like this. So let's say it's positive x, such that x is a positive multiple of 2. So the listing method means I list some numbers, but I can't list all the multiples of 2 because it would be an infinitely long thing. So I'd say, okay, positive multiples of 2. So 2 times 1, that's the first multiple of 2. Multiple of 2 means multiplying this by 1, 2, 3, 4, 5, 6. 2 times 1 is 2. 4 times 2 times 2 is 2. 3 times 2 is 6. 4 times 2 is 8, but I've already listed 3, so I think that's enough. Then I go dot, dot, dot. And because it doesn't have an upper limit, the lower limit is specified by this positive thing. So the left-hand side does have a fixed limit, whereas the right-hand side doesn't. If I said, for example, x, let's say x is a multiple of 2 without the positive part, then it would go something like this. You'd start out with dots to show that you're coming from negative infinity, and then I would have something like -4, -2, 0, 2, 4, dot, dot, dot. So this would just be associated with it. So it's like this, except I include the negative multiples. And I also included 0 because 2 times 0 is 0. And that's a good question. Is 0 a multiple of 2? Do you include the 0 thing? To be honest, I am not 100% sure on that one. So, okay, so that's that. We talked about the cardinality of a set. And the cardinality is just, find the cardinality of a set. The cardinality is just the number of elements. So you don't have to use any fancy formulas or anything like that. You just have to look at it. So let's say set A is Monday, Tuesday, I'm just using abbreviations here, Wednesday, Thursday, Friday, Saturday, Sunday. So it's 7 days of the week. So I go 1, 2, 3, 4, 5, 6, 7. So n, which is the number of elements in the set, is 7. So actually, we just count them. And what we would say is the n of A equals 7. So just count the elements, number of elements in the set. And then write n of A. N of A means that the cardinality of set A. and 1, 2, 3, 4, 5, 6, 7. Okay, so that's easy. Now let's say I did something more like this. I said the set is 20. And I said, what is the cardinality of B? Well, you wouldn't go 1, 2, 3, 4 because that wouldn't include everything. So you have to almost write it out. 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2. Now that I have it all written out, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the cardinality of the second set. Okay, then you're going to answer the question, is something a subset or a proper subset of, or not a subset? I guess it's either a subset or not a subset. So if I were to give an example, so what you would see is without this thing in the middle. Okay, so we're going to leave it blank, and you have to put it in there. So so the question is, the definition of subset, it says every element in this set has to be in that set. Well, you see that the A is there, the B is there, C is there, but the B isn't. So because of that, this is not a subset. If I had something like A, B, F, and on the right-hand side I have A, B, C, D, E, F, then I would say it is a subset because this maps there, that maps there, and that maps there. Now the other way around wouldn't be the case. If I had this to the left-hand side and this to the right-hand side, it would not be a subset. But remember, the order is not important. So if I said is, if I said F, B, A, I compared that with A, B, C, D, E, F. Here they're in alphabetical order. A, B, well, A, B, C, D, E, F, and here they were A, B, F, so they matched up kind of in alphabetical order. These are in alphabetical order of the letters that are shown. Here they're not in alphabetical order, but this is still a subset. Okay. And you might have something where you have a description like this, and then there's a space in between, and on the right-hand side, instead of having a set, you may have it in set builder notation. So you might have something like that. So here we have 1, 2, 3, 4. Here there's a set where X is a whole number. Well, 1 is a whole number, 2 is a whole number, 3 is a whole number, 4 is a whole number. So in this case, it would be a subset. Now, in all these cases, these subsets would also be proper subsets because the only time it's not a proper subset is when if these were identical to each other. Okay, then we're going to tell whether statements are true or false. We talked about that in class. So let me just give you 1 or 2 examples here. So let's call this the universal set. And we'll say set A is And we'll say set B is such. Okay, so you'll be given something. You'll be given a statement. And if you said, A is a, well, actually, I don't know if you noticed, probably made an error here because the universal set should include all things. And that did not. Well, no, that's okay. Still the universal set. So if I said, is a subset of U, and I asked you whether it's true or false, what you do is ignore that, look at your sets, and make some conclusion yourself. So this is what they're saying. You ignore that for right now. You come over here and say, okay, how is A subset or not a subset? So you look and they see that every element in A is in the universal set. So my conclusion would be that A is a subset of U. If their answer is the same as your answer, then it's true. So if I were to say, ask you to comment on the truthfulness of this particular statement, so if I said A is a subset of B, is that true or not? So you go over here and okay, I don't care what they said. Let me see what I say. So so is every element in A and B? Well, this one's in A and B. This one's in A and B. This one's in A and B, but 5 is not over here. So I would say A is not a subset of B. And when I compare these two, they're different. So since what I concluded and what they stated are different, so if you get different answers, then you would say it's false. Okay, so you got a couple of problems where I ask you some questions about whether they're true or false, and that's kind of the way you answered. And then the final problem involves the number of subsets. So we talked about that in class, and don't list anything out. You got a formula for that, for both actually, a number of subsets and number of proper subsets. So let's say set N is, again, Monday, Tuesday, Wednesday, Thursday, Friday. So it's the set of weekdays. And if I ask the question, how many subsets are there, you wouldn't start listing all the possible subsets. But what you do is you go, okay, I want to count the number of elements. So the number of elements, or the cardinality of the set, is 5. There's 1, 2, 3, 4, 5. Okay, don't need a calculator for that. So 5. So you say, oh yeah, that formula. Don't want me to write down. The formula says the number of subsets is 2 to the n. So it's always 2. N is whatever the number of elements in the set. So you do 2 to the 5th power, and hopefully your calculator has the exponential function in. If not, you can just remember that 2 to the 5th is just 2 times itself this many times. So that would be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So there are 32 possible sets that you can get. 5 element sets, 4 element sets, 3 element sets, 2 element sets, 1 element set, and the null set. Now the number of proper subsets has this equation, and the number of proper subsets is 2 to the n minus 1, so it's going to be 31 for this example. So make sure you write those down in your sheet, and you understand you just count the number of subsets. So that's it. So it's not really that hard, and people usually do well in the first test. Second test, third test are more difficult. So don't think, oh, this class is so easy and I don't have to work anymore. People have a lot of trouble with logic and truth tables, which is chapter 3, and they have problems with the remainder of Chapter 2, which is looking at Venn diagrams and making conclusions about the number of elements associated with various operations, which we'll talk about on Monday. So there are people who have finished this first test in like 20, 25 minutes. And that's fine with me. Right now we just need to get you a grade and make sure you have been at least paying some attention. So, where's my tab? Whoops. Being delayed here, but it shouldn't take too long. So it's going to be like one of the homework assignments where you have, here we go, okay. So we're going to ask you to answer the question, is the following a subset, proper subset, both proper subset and subset, or neither? Meaning it's not a subset or it's not a proper subset. And in reality, so if you listen to this, there's really only three choices. So the choices I give you are subset, proper subset, both, and neither. But the thing is that if it's a proper subset, then it's a subset. So we don't really ever have the case where it is a proper subset but not a subset. So it's either both, meaning it's a proper subset and a subset, or it's a subset, or it's neither. So you just, really there's only three choices. But it'll still give you the four choices in there. Just in case you don't watch the review video, then you're in trouble. Okay, so let's just make up some sets here, and I'm going to use numbered sets instead of letters. So I'll make set A the bigger one. So let's make set B something like this. And set C and set D and set E So I'm going to give you some sets like that, and then there are going to be some questions. And what it'll be is it'll be a blank line, and you have to fill it in. So I might do something like B is what relative to A. So this is set B. So is set B a subset? And so you compare, and they both got 1, they both have 7, but this one has 11, that one doesn't. So what you would do is you would say it's neither. It's neither a. So if it's not a subset, then it certainly can't be both, and it can't be a subset. So you can't ask that question. Is it a subset? If it's not, then it's neither. Okay. So let's do C. C is what relative to A? Well, every number that's in C is also in A, so it's a subset. But because these are not identical, then it's not a proper subset. I mean, it is. Sorry, it is a proper subset. So the only time it wouldn't be both is if A and C were exactly the same. Then it would be a subset, but not both a proper subset and a subset. So in this case, we would say it's going to be both. C is a subset of A, and it's also a proper subset of A. Okay. Let's do D is what relative to C? So here's D, here's C. So we're going to compare this. Is every element in set D in set C? And the answer is yes. So it is a subset. And again, because it's not exactly equal to that, then it is also a proper subset. So it's going to be both. So D is both a subset and a proper subset. So if I said, how about B relative to E? Set E relative to E. Well, you can see that they are the same. So this is the one case that it's just a subset. So B is a subset of E, but it's not a proper subset. So it's not both. So I guess the bottom of the line is if, I don't know if I want to write it out, it's just the only case where it's not both, if one is a subset of the other, is when they're identical to each other. So that's the special case. So let me do an F just to show another example to reiterate the point there. So again, in this case, F is just a subset of A. It's not both. But if I were to, let's say, I wanted to do relative to C, but D relative to F. So here's D, here's F. So 3 is in both of them, 5 is in both, 7 is in both. So every element in set D is an element in set F. Therefore, it is a subset. But because they're not identical to each other, they're also a subset. And so in this case, they're both a subset and a set. How about C? Actually, how about A relative to set C? So we know that from earlier that C is both a subset and a proper subset of A. But the other way around, is A subset of C? Well, no, because not every element in A is a element in B. Some are, but you got all these other extra ones. This one has more terms than this, so it can never be this could never be a subset of that. You always have to have at least less terms. And then once they're either the same number, like in this case, or lesser number, equal to or lesser number of elements, and then they have to match up. So in the case of A, is neither a subset or a proper subset, so we put neither there. Let's see if there's anything else I can point out. Anyway, so that's how the problem works. So if it's not a subset, then it's neither a subset or a proper subset. If it is a subset, but it's not identical to the other set, then it's both. It's both a subset and a proper subset. The only time that it's just a subset is when they are, one is a subset of the other and they're also identical. They're equal to each other. Then it can only be a subset. It cannot be a proper subset under